Hi, this is Dr. C, and I'm going to talk to you about programming in Python, and I'm going to go over the basics of Python from the perspective of a Java or C++ programmer, just to give you a sense of the comparison between Python and Java. So we're going to be looking at the following aspects of Python versus Java, C++. I'm going to show you how to get started, work with variables, then we're going to take a look at control structures in Python, the if, the while, the for, then some reflections on writing code, then we'll look at object orientation, take a look at some of the data structures that Python provides, and then take a look at how to work with libraries. So let's get started and take a look at Java versus Python. So here we are in NetBeans. I created a project called 5311 Java Demo, and I created a class in the default package. Java likes you to have packages. Packages are part of the Java framework, but as we're going to see in Python, we don't really have to worry about this kind of thing. Just to do a simple hello world program, print hello world, requires at a minimum 3 lines. We've got to define a class in which we can place a main function, a main procedure, and in there we do system out print line and we print hello world. So from the Java runtime we can select run file, and see we down here we have our output hello world. Now what would the equivalent thing look like in Python? Well, let's take a look. So here I have the PyCharm Educational Edition Interactive Development Environment, which I recommend you download and use. And I've got a project created. I created with File, New Project. So I've already created a project called 5311 Start, and I'm going to right-click on this, and I'm going to create a new Python file. So we're going to name the file. Let's call it test. Hit OK, and it comes up with the author based on the name that I registered the software with. Now, Python is very different from Java or C++ in that it is not a pure object-oriented language. So it allows both functional programming and object-oriented programming. So I can simply print hello world right here in the program, and there are ways to use a kind of interpreter in Python, but I'm just going to run this editor, and I'm going to compile this program. And so I can select run. Oops, the wrong one. Okay, let me run my this is the one I've got here, test, and I'm running test. And here in the output window right below, we see hello world. So very interesting, very simple to generate output, to write some code. There's not a lot of boilerplate in Python as there is in Java or C++. So just to get something done is pretty straightforward. So here we are back in our Java world, and I'm going to declare a variable. In order to print the variable in main here, I'm going to have to declare the variable to be static. So I'm going to say static int. Now I need to declare the type. Java is a statically typed language, so I've got to declare the type of the variable, and I'm going to say static int x equals 22, and that will allow me down here to say hello world, and I'm going to use string concatenation plus to show the value of x. So if we take a run, we're going to run the file here, and there's hello world 22 as it appears there. Now also in Java we have a number of different data types. So I can have a double equal 22.333. I can, let's see, need a semicolon at the end of the line. I can also create a string. I'm typing here. So I've typed in the line, but it's reporting an error. So one of the things I can do in NetBeans is I can see what the error is. So most of the IDEs have a little exclamation or red mark, so I forgot to declare my string variable name. And so we can simply now extend, see if this is going to work, print it out again with my system out print line. So here's how we do things in Java. And then we get our output down there. Now let's see how we might do the same thing in Python. So in Python, we can do the same thing. Here, let me show you a Python comment. Declaring variables, and dynamic typing is what Python uses. So I can say x equals 22. I can say z equals 99.77 to create a double. I can create strings with double quotes. And notice we do not need a semicolon at the end of the line. Again, Python it can be quite efficient in typing. Strings also can be created with a single quote. This is unlike Java. And among the data types that Python supports are the Boolean. So I can just declare a variable is happy equals capital TRUE, true. The opposite of that is going to be is sad equals false. So we've got some comments, and we just simply declare variables as we need them. These variables are going to be available to the entire program, and we don't need the semicolon after the declaration. But now let's look at control structures and see how Java versus Python does their ifs and while statements, were the two main constructs. So in Java, if we want to create an if statement, we do it as follows. So here I have an if statement with an else, and my expression is going to be in parens. If x is less than 2, then we want to print x less than 2, else we're going to print x greater than 2. So what would this look like in Python? Let's have a look. So here in Python, we can do the same thing, but I'm going to add a little comment. Python does not require curly braces or semicolons. It uses indents. So the very nice thing about Python is we can simply write some code if x less than 2, and then we put a colon, and the Python editor automatically will indent for us. Print less than 2. I'm going to go back here, and I'm going to do my else. We also need a colon because we're going to go indented greater than, or let's say not less than 2. And so this is what our code looks like. So a couple of things to point out. We do not need or require parentheses around a Boolean expression here. We outline the end of the if with a colon, and then indented underneath is everything else that we want to print. So let me just add another print statement in here. Print second line. So everything that we want to do under this if is simply lined up with the proper indentation. So let's run this little start program. Well, my test program. And here we have the output. Hello world from up here, and not less than 2 because x is going to be 22. So the first major thing that distinguishes a Python program is its use of indentation to structure the program. And it now eliminates the need for semicolons and the need for curly braces, which can be very nice. So let's look at how we do a while statement in Java and in Python. Here I've got the NetBeans set up with a very simple while statement. While x is greater than 15, system out print line, and then we print the value of x, and then we decrement x with the minus operator. So as you look at this, think about how Python might do it before I show it to you. So x greater than 15, and we'll run it again here, and run the file, and there we get our output. Just drops down. As long as it's greater than 15, we print our output. So while statement again uses the parens and the curly braces and the semicolon. But let's look at what Python does. So here we are in Python. Let's see how we might do the same kind of thing in Python. So I hope you thought about this. While x is greater than 15, and we got to put our colon. Notice we're getting the red indicator. It indicates that our syntax needs something else. So while x is greater than 15, and then my editor gives me my automatic indent, print x equals, and now remember in Java we did x minus minus, but when we do that we get a syntax error. This is one of the possible gotchas from going from Java, C++ to Python. Python does not have a minus minus or a plus plus operator. One possible reason for this that's been discussed is that people in Java and C++ always get confused what plus plus x or x plus plus does when the increment happens. There's a bunch of confusion associated with that. So what we're going to do is simply print x, and then I'm going to decrement x, and I decrement x this way: x minus equals 1. That's the same as saying x equals x minus 1. Now, there's going to be a problem with this, but it doesn't show up right here. It's going to show up at execution time. So let me run this. And notice that we get a runtime. And this is what happens when you're not dealing with a statically typed, compiled language like Java, C++. A lot of some of the error messages come out at runtime. So there's actually a type error. The plus operator is a string concatenation operator. And x is not a string, it is an integer. So if you try to use the plus in a print, you've got to make sure that whatever you are trying to print is a string. So how can we turn an integer x into a string? Well, we simply use a string function. We pass it an argument of any variable type, and it will convert it to a string. So now we should be able to run this. And here, as you can see on our output down here, can't see all this, but x 1221 goes down to x equals 16. But that's how we do it. So the while, no parens, a semicolon, and then we indent, and we get our while loop. So there it is. So let's look now at writing code in a little more detail than we just looked at, and we'll take a look at writing a function in Java. So here we have a small Java program. What I've done is I've created a static function called compute area. It takes an integer as a parameter and returns a double. That's going to be the area of our circle, pi r squared. To get pi, we can simply use the math library, capital math.pi, which is a constant defined in that library, and I can multiply it by r times r. Down here in main, I'm using a static main to call a static function. Compute area, I happen to catch the return value in a variable called area, which is going to be of type double, because that's what compute area returns, and here I simply print out the area. And when I do this, I get area of a circle 1520. So the key thing to take away from this Java example is we're not dealing with objects yet, but we've got to live in object land. We've got to define a class, and in that class we've got to define static methods or static functions. And then, even though we're not using any object-oriented features, we still need to operate in that object-oriented context. Very different from Python, where you can either do objects or you cannot. So let's look at how Python does that. So in Python, we don't need to declare a class. We just simply define a function with the keyword def. So def, I'm going to call this compute area, and it takes a parameter, the radius. Again, here I don't need to specify the type because we are in dynamic typing land. So the interpreter and the compiler will figure it out for us. Now we need a colon, and now everything that's part of this function is going to be indented under the function. So I simply hit enter. If you're using a regular text editor, you can just use tab or use some spaces. You've got to make sure that you have the same number of tabs or the same number of spaces with respect to the indentation. So we're going to return. Now we need to get pi. So let me show you this. So I can say math pi times r times r. So it looks a lot like the Java, except I'm getting an error here. Unresolved reference to math. More. Control F1. Let's see what Control F1 says. This inspection detects names that should resolve but don't due to dynamic dispatch and duck typing. This means if it looks like a duck, it is a duck. It is possible. So what we're really missing here is an import. So we need to tell Python that we want to import from the math project, and now our editor and our compiler interpreter is going to be happy. So here again I can simply just define a variable equals compute area. In fact, I've got this little handy pull-up here, which I didn't use, but area, compute area 22, and then print area. And again, this is working in the IDE is lovely because it gives you suggestions or whatever you want to do. So let me just leave it at that. I'm going to hit Control Shift F10, and here we are, output 520.53 whatever. So the key takeaway here, define functions, and we're going to be defining a lot of functions because there's a whole wave of programming style that's concentrated around writing simple functions that get your work done. So we use def. Here's our function. We don't need a data type, and we simply return our value, and we now know how to write Python functions. So let's now take a look at how both Java and Python deal with object orientation. Okay, now let's look at Java and how we might create some objects. So I'm going to go to my default package here, and I'm going to create a new Java class. I'm in NetBeans. I'm going to call it asteroid. So we're going to have some asteroid objects. I'm going to get rid of this. So imagine we're creating some kind of graphics app where we have asteroids positioned on the screen at some XY coordinate. So I'm going to declare some private variables, keeping with the philosophy of object orientation, to keep the data private, and then we're going to add some accessor methods. Oh, but before we do that, I want to add a constructor. So we've got to add a constructor. Constructors have the name of the class and are public, and they take parameters which then get fed into the constructor, and we now have this x and this y set to the parameters y. So the internal data of the asteroid is going to be set. And now we want to add some accessor methods because our data is private. Let's look at how we do that. Okay, so we've set this up. We've got a function called compute distance, and it takes as a parameter some other asteroid, and we're using our distance formula here. So I compute the distance between our x value and the other x value, and then the y distance between our y and the other y, and then I square those values, square the dist x and square the dist y, and then we use the math square root function to get our result back. So let's see how we would actually use this in our program. So let's add some code here, adding a function or a method to our object called compute distance. But now we're going to create a static method called main here. And let me get rid of these zeros. And so we're creating an instance of the asteroid class. I'm calling it A1. It's going to be at 0, 0, and another one at A2 at 3, 4. And then I print out A1. We tell A1, compute the distance to A2, and we execute the code up here, and we get our result 5. So very basically, we've set up an object. We have instance variables x and y. They're private. We have a constructor, and we have accessor methods getX and getY, which refer to this x and this y, which are part of the instance. So let's look at how we might do that in Python. Well, the way I want to show you how to do objects in Python is to begin with the Java asteroid class. So let's just kind of step through the class real quickly, and what I'm going to do is show you how you can transform a Java class directly into a Python class by just a few strokes of the keyboard. So here's our class asteroid, and we're adding extends object. So if you're doing inheritance, you could say extends from some class. Actually, in Java, this is the default, so you don't have to do anything. We've got two private instance variables, x and y, as part of our class. We've got our constructor down here, which allows us to pass in values for x and y and keep those as the instance variables. Then we have a couple of accessor methods, getX and getY, that return the value. Notice we're using this to refer to the instance variable. And then we've got another capability for our class called compute distance, where we pass it another asteroid, and it computes the distance between itself and the other asteroid using the distance function, where the distance squared equals the distance in the x direction squared plus the difference in the y direction squared. And then we've got a main to actually run this, where we instantiate our two instances of the asteroid class, and we print out the result of asking A1 to compute the distance to A2. So I'm going to grab all this with a Control-C copy, and then I'm going to go and open up my PyCharm, and here we are I've got a project here, so I'm going to create a new Python file, and I'm going to call it asteroid, and we've got a little author thing there. So I'm going to paste my Java code in here. So we're going to have some fun with this. So here is a Java class in a Python, the Python editor. So what do we know about Python and what it doesn't have? We know it doesn't have semicolons. So I'm going to do a replace, and I'm going to replace all the semicolons with nothing. So we'll get rid of the semicolons. The other thing that Python does not have are the curly braces. So let me start by replacing the closing curly brace with nothing. Okay. Now, for the opening curly brace, the corresponding thing in Python is really the colon. And if I've written my Java where I keep the open curly brace on the line, then we are getting close to where we need to be. So let's take a shot at this. In Python, there is no public, private, and protected. So all the data in Python is publicly available to the outside. So let me see. That's probably the easiest thing to do. We're going to get rid of the word public, replace it with nothing. There is no private in Python, so I'm going to replace all the private with nothing. And now let's go down here and start working on this. So here's our class asteroid. The extends keyword is not in Python, but instead there is simply a parentheses where we can specify the class that we are inheriting from. So lowercase object, there's our asteroid class. Now, there's no need in Python to declare your instance variables. So I'm going to take these instance variables that came out of the Java world and just get rid of them. Okay? So now we're left with the, now we're going to deal with the constructor. So we've got to indent. So our class is over on the left-hand side, and now all the methods, the functions that are going to be part of the class are going to be indented. Now, Python has a peculiar way of doing the constructor. Instead of using the same name as the class, we do underscore underscore init. That is the magic term for the constructor. And since it's dynamic typing, we don't put any data types on the parameter line. So just X and Y. We let Python figure out what these things are. Now, in Python versus Java, one of the big differences is the word this. The word this does not appear in Python. Instead, Python uses the word self. So let's go up here, and every time we have the word this, I'm going to replace it with the word self. And that's going to get us close to where we want to be. So now let's look at this constructor. We're getting an error here in terms of the word self, unresolved reference. Now this leads to the probably the most unusual thing, if you're not accustomed to Python, is every method, the constructor and all the other methods, need the word self as an implicit parameter to the methods, the functions that are defined as part of the object. So every time we have a method defined, we need to put this self here. We don't need to pass it in as a parameter. We just need to have it there. I'll show you how this works in a minute. So down here we have the getX. This is going to simply be replaced by a def. And inside, there are no parameters, but we've got to put the magic self in there. So see how that works? Def get y, self. You notice how the little red lines are going away. Down here we had a function to compute the distance. Returns a double. We don't specify the return type. We just say def compute distance. And since it is a method part of the asteroid class, we've got to put our self in there. We don't have data types, so all we need to do is say self other a. Down here we have the distance. We can simply eliminate. So what I'm doing is I'm turning the Java into Python by simply removing a bunch of things. So now we have our distance. Okay, I've got a Java comment. I got to replace that with the pound sign, which is the Python comment. And now the only thing, now we're coming down here, we got this capital M, unresolved reference to math. Actually in Python the math library is math lowercase, and in order to use it I've got to import math. There we are, math. So importing math, and now that's pretty good down here. And now, here is our public static void main of Java. Again, none of this boilerplate is necessary. So I can get rid of this whole line. And now, here's my A1. Again, we're in dynamic typing. So notice what I'm doing here in the main part of the program. I'm just moving it over to the left-hand side, and this becomes this is going to be code that's going to be executed. So here's A2. Let's go back to that in a minute. System out print line. There's no system out. All I have to do is say print and get rid of these parentheses. Okay, and now I'm confronted with this problem with new. Well, again, Python is lean and mean. We don't even need the word new. We just say A2 is asteroid 00. A2 is asteroid 34. A1 is asteroid 00. Print A1 compute distance. So now I've turned the Java program into a Python asteroid class. So now we can run this. See what happens when we run it. I run the asteroid, and here we are in the display window. 5.0 is the distance between the two asteroids. So the key takeaways are the constructor, where you use underscore underscore init underscore underscore. Every method that's defined as part of the object appears, the first parameter is self. And again, notice, for example, we can see that here, computing the distance, it looks like the function takes two parameters. Behind the scenes, it is taking two parameters, but we only need to pass the parameters that are not the self parameter. So this can be a little tricky. But notice we didn't have to define instance variables. We just simply say self.x, and now we have an instance variable called self.x. Self.y, here we have an instance variable called self.y. So that's, in a nutshell, how Python object-oriented programming is defined and set up.